Analysis of the effectiveness of using machine learning algorithms to make hiring decisions. In this presentation, we review the relevance of the subject area and identify the main objectives of the experiment. Consider the methods and materials used to solve the problem. Also review in detail the steps of the experiment and the results obtained. Finally, based on the results obtained, summarize and formulate conclusions. Hiring is a critical process for organizations. It has a direct impact on business success, and poor hiring decisions can result in significant negative consequences. Hiring process involves a set of steps to recruit, evaluate, and select new employees who can contribute to the organization's success. These steps typically include job posting and recruitment, resume screening and initial interview, testing and background checks, final interview, job offer, and acceptance. The traditional hiring process can be time-consuming, costly, and subjective, leading to potential biases and errors in decision-making. As such, organizations have begun to explore the use of machine learning algorithms in the hiring process to improve its efficiency and effectiveness. The purpose of this work is to experiment with decision tree algorithms and determine the effectiveness of their use in the recruitment and hiring process. The task of the worker: perform a series of experiments using different machine learning algorithms. Evaluate the effectiveness of each algorithm based on evaluation metrics. Compare and select the most effective algorithm for making hiring or rejection decisions. Consider the methods and materials used for the experiment. And let's start with the preparation of the data. The preparation of a dataset is a critical step in the process of predicting the suitability of candidates for a job. To solve the problem of hiring classification using machine learning algorithms, it is necessary to collect relevant data on job candidates. This can be personal information about the job candidates, such as their name, age, gender, educational and previous work experience, skills data, feedback and recommendations from previous employers. The dataset used for the experiment includes information about the candidate such as gender, work experience, education, internship, score, salary, offer history, location, and recruitment status. An attribute of prediction is recruitment status. In the presented diagram, you can see the quantitative characteristics of the dataset by the resulting attribute. One of the many solutions in solving hiring problems is to use decision tree algorithms because they are well suited for classification problems, which is a typical use case in the hiring process. Decision tree algorithms allow decision makers to evaluate different criteria for each candidate. The most common decision tree algorithms were used to train the classification models: decision tree, random forest, and gradient boosted trees. The presented diagram shows the structure of the decision tree, which consists of three main parts: the root node, the leaf nodes, and the branches. The root node is the starting point of the tree, and the root and leaf nodes contain the questions or criteria that need to be answered. The branches are arrows connecting the nodes and showing the movement from question to answer. Each node usually has two or more nodes branching off of it. Several evaluation metrics, including accuracy, precision, recall, and F1 score, were used to evaluate the effectiveness of the model. A high recall score indicates that the model effectively identifies positive examples and is defined as the ratio of the number of true positive examples to the total number of actual positive examples. A high precision index indicates that the model effectively determines only positive examples and is defined as the ratio of the number of true positives to the total number of true positives. A high accuracy rate indicates that the model effectively predicts both positive and negative cases and is defined as the ratio of the number of correct predictions to the total number of predictions and represents the proportion of cases that the model correctly classified. F1 score is the harmonic mean of precision and recall and is used to evaluate the overall performance of the model in correctly identifying positive instances while minimizing the number of false positives and false negatives. Based on the algorithms that were presented on the previous slide, we developed software to train the model. To implement the software, we used the Java programming language using the Spark framework. The process of training a classification model involves several steps. The first step is to prepare the data for the model by cleaning and processing it. The next step is to divide the data into two sets, a training dataset and a test dataset. For the experiment, the dataset was divided in the proportion 80:20. In the presented diagram, you can look in detail at the quantitative characteristics of the datasets. After splitting the data into two separate sets, a decision tree algorithm is chosen and the model is trained on the training dataset to learn how to make predictions. Once the model has been trained, it can be used to make predictions on the test dataset. Predictions can be compared to actual values on the test dataset to evaluate the effectiveness of the model using evaluation metrics. After analyzing the evaluation metrics, the model can be fine-tuned to improve its performance. Consider the results of the experiment. The training time for the decision tree model is 0.803 seconds. The model achieved an overall accuracy of 74.75%, with precision and recall scores of 100% and 23.5%, respectively, and an F1 score of 68.95%. The training time for the random forest model is 0.964 seconds. The model achieved an overall accuracy of 78.6%, with precision and recall scores of 100% and 35.3%, respectively, and an F1 score of 75%. The training time for the gradient-boosted trees model is 1.728 seconds. The model achieved an overall accuracy of 79%, with precision and recall scores of 75% and 17.6%, respectively, and an F1 score of 64.2%. Based on the comparison results, the random forest algorithm is the most effective in terms of achieving higher overall accuracy, precision, recall, and F1 score, outperforming both decision tree and gradient-boosted tree models in all metrics. However, the training time required for each algorithm varies significantly, with the decision tree being the fastest and random forest and gradient-boosted trees taking longer. Based on the results, consider the summary. The Gini index and entropy criterion had minor impact on the performance of the tree models, with entropy slightly outperforming Gini. The random forest algorithm achieved the highest overall accuracy, precision, recall, and F1 score among the three algorithms tested. The effectiveness of each algorithm is highly dependent on specific variables, so it is important to adjust these parameters to optimize model performance. Machine learning algorithms should not be used to make the final hiring decision, but rather as one of many tools in the hiring process. In conclusion, we can say that several experiments were conducted using different decision tree algorithms. The effectiveness of each algorithm was evaluated based on the evaluation metrics. The most effective algorithm for making hiring decisions has been determined.